Let's understand what makes a function bijective and analyze the function f of x equals 3 minus 4x. A function is bijective if it is both injective, or one-to-one, and surjective, or onto. Let's first look at our function. We have f of x equals 3 minus 4x, mapping from the real numbers to the real numbers. Let's visualize this linear function. Let's first check if this function is injective. A function is injective, or one-to-one, if different inputs always give different outputs. Mathematically, if f of x1 equals f of x2, then x1 must equal x2. Let's prove this algebraically. Assume f of x1 equals f of x2. This means 3 minus 4x1 equals 3 minus 4x2. Subtracting 3 from both sides, we get negative 4x1 equals negative 4x2. Dividing both sides by negative 4, we get x1 equals x2. Therefore, our function is injective. Next, let's check if the function is surjective. A function is surjective, or onto, if every element in the codomain is hit by at least one element in the domain. In other words, for any y in the real numbers, we need to find an x such that f of x equals y. Let's prove this algebraically. For any y, we want to solve the equation y equals 3 minus 4x. Subtracting 3 from both sides, we get y minus 3 equals negative 4x. Dividing both sides by negative 4, we get x equals 3 minus y over 4. Since this gives us a real value of x for any real y, our function is surjective. Let's visualize why this function is bijective. Notice that our function is a straight line with a non-zero slope. This means that 1, it passes the horizontal line test, showing it's injective, as each y value is hit at most once. And 2, it passes the horizontal line test, showing it's surjective, as each y value is hit at least once. Since our function is both injective and surjective, we can conclude that f of x equals 3 minus 4x is indeed bijective.